of talks, as you can see in this on my screen. Um,
Hello.
your teachers and your principals are well aware of all these really awesome presentations. This week, I presented, Dr. Alfonso Davila presented, and Dr. Dave Demaray. And today we have another special guest. Listen to you. Okay, today we we have Dr. Fernando Abillerira, who is currently serving as a March 2020 Deputy Mission Manager for launch through landing on Mars. Fernando Abillerira has been working at NASA for almost 20 years, and he was part of the teams that successfully landed the Curiosity rover in 2012 and the InSight lander in 2018 on Mars. His areas of expertise include astrodynamics, mission design and navigation trajectory optimization, and flight operations. Wow, we are so honored to have you, Dr. Abillerira, with you. And remember, let's give the courtesy to Dr. Abillerira of presenting his remarkable work. Okay, let's all keep our mics muted so that we don't interrupt him. And then at the end, we're gonna allow you to ask a bunch of questions, okay? Is that a deal? All right, so Dr. Abillerira, please begin sharing your presentation and let's get started.
Good afternoon, everyone. So thank you for joining us today. I really appreciate it. It's my pleasure to have an opportunity to share with you, the incredible world of space exploration, in particular the exploration of the red planet. So there's something very exciting happening in a couple of weeks, and I hope that you guys are as excited as I am. So you're gonna learn a lot about what's going on, what we're gonna be doing, how the Mars 2020 Perseverance rover is doing right now. And I hope at the end of the presentation, you're just thrilled to mark your calendars for February 18th, which is when we are planning on landing on the red planet. So please let me know if you have any issues with the slides or the videos, and then I'll be more than happy at the end to answer any questions as well as I can. Okay. All right, so I hope my presentation is very entertaining, dynamic. I have a lot of images and videos, and I think that that's important because you guys would appreciate it more than if I talk for a while. But the first video that I have just shows a few images that perfectly capture the challenges that we had to overcome to make this mission possible, from formulation and integration, putting the spacecraft together, sending it to the launch pad, integrating it with the rocket. So there's a lot of people that have worked on this project. We're talking about thousands of people from all different backgrounds, from all different countries, everybody doing their very best job to make sure that this is a successful project. those people doing incredible work just to make it to the launch pad, right? And that was just one little milestone on our journey to the red planet. And you might be wondering, well, so why Mars? Why we have this fascination about the red planet? Why do we keep sending spacecraft to explore the red planet, right? So at first sight, Mars actually appears to be a very boring, dead place, a place that could not harbor life. Not now, not ever. It's full of craters. It kind of looks like the moon. There's just nothing there. There's no vegetation. There's no water on the surface that we can see. But in reality, Mars actually wasn't always like that. Mars used to have rivers, lakes, oceans about 3 billion years ago. So Mars was very different than it is now. And it's very interesting, right? Because we know on Earth, where there's water and there's a source of energy like the sun, there's the potential for life. So why is Mars a priority for exploration? Yeah, we talk about the potential for past and present microbial life. It's a planet that is relatively close. It's a planet that looks a lot like the Earth, relatively speaking, obviously. It has the potential for future life because it has a lot of resources that we can utilize if we send a human crew to the red planet. And it has really fascinated the public for many, many years, right? So some of these pictures, I'm an engineer, I'm not a scientist, but from a scientific point of view, I'm just as excited as they are. Because if you look at these images of Mars, it almost doesn't matter where you look. It's very obvious that Mars used to have a very wet past, right? With some kind of liquid flowing on the surface. You can see ancient lake delta formations caused by rivers. You can see ancient riverbeds. You can see sedimentation rings. We have found minerals that only exist in the presence of water, like hematite. Back in 2008, in May of 2008, the Phoenix landed near the North Pole, and we actually found blocks of water ice. You can see on the picture on the left. So we landed on this location, and we stirred the surface a little bit, and we saw these beautiful blocks of water ice. So, I mean, we know now that there's still water on Mars under the surface in a frozen state, and also mixed with frozen carbon dioxide on the poles. Why is Mars a top priority? Well, we talk about that, right? And it's very clear that we have an interest to visit the planet. We actually have gone to Mars since the 1960s in 14 times, and sometimes we have used more than one spacecraft. We have sent more than one spacecraft in each opportunity. Opportunities between Earth and Mars open up every 2.5 years. That's when the relative position between the planets is optimal. And during these missions that we have sent to Mars, we have actually had many first ever events, like the first flyby another planet, the first landing on another planet. But the reality is that Mars is not an easy place to go. In fact, more than half of all the missions sent to Mars by all agencies around the world have failed. The good news is that the last 10 missions that NASA has sent to Mars have been successful. So we're very hopeful and very optimistic and confident that in just a few weeks we'll have number 11 with Mars Perseverance. A few months ago, someone mentioned this to me, and it's a statement that has resonated with me, and it's the fact that no 20-year-old or younger has lived a day without an operational NASA spacecraft on Mars. So that's fascinating to me. For you guys, it's kind of normal. Oh, we have a robot, exploring Mars. But it didn't used to be that way all the time. So we have come a long ways. So I mentioned in passing that water is very important. So that was the focus of many missions in the past, including the Mars Exploration rovers. But the Mars Curiosity rover that landed on Mars back in 2012 was really focused on searching for habitats that could have been suitable for life. The next step of exploration, now that we have confirmed that the landing location of the Curiosity rover had the conditions necessary for life, is to actually search for life itself. And that's one of the main goals of the rover, of the Perseverance rover. We're looking for evidence of past life on Mars. Now we're gonna talk about Mars 2020 Perseverance in a little detail, and I hope that you guys are as excited as I am. So obviously we only have one rover, so we can only explore one location. You can imagine that scientists around the world are super excited about this, but we only have one vehicle, so we can explore only one location. Years ago, there were more than 60 different candidate landing locations. And over time, they started down selecting all those locations until they found the ideal one for this mission. That is called Jezero Crater. That site was selected at the end of 2018. And the project has been working really hard, assembling the vehicle, and we actually shipped it to Cape Canaveral in Florida for launch in early 2020. Our launch period extended from July 30th through August 15th. And we actually launched on the very first day of our launch period, July 30th, at 4:50 a.m. Pacific. So the very first day, on the very first opportunity, we were on our way to Mars. So that was a great day for everybody. Our cruise duration, the duration of our trip between Earth and Mars is about 7 months, and we're almost there. We're less than 2 weeks away from arriving to Mars. The Mars landing, and I want you guys to remember this date, is scheduled for February 18th. So that's a week from next Thursday. And we're expecting to get confirmation of a successful landing at around 12:55 p.m. Pacific time. So make sure you mark your calendars for that. It's going to be very exciting. It's going to be hopefully during your lunch break, so you won't even be missing school, so you can watch along with us. And our primary mission is about 2 Earth years, about 1 Mars year, but the spacecraft actually has been certified for a longer period of time. Now, talking about the objectives, we talk about investigating the possibility of life on Mars. We're going to be gathering a lot of information that is going to tell us more about Mars habitability. We're going to be searching for biosignatures that have been preserved, that may have been preserved in rocks, and that could serve as evidence of past microbial life. We're talking about microorganisms that could have existed on Mars 3,000 million years ago. And something that is very unique about this mission is that the most relevant samples are going to be stored for their potential return to Earth by a future mission. And you might wonder why that is important. And even though we're planning on landing the most powerful rover on Mars that we have ever sent to the red planet, and we have a very powerful suite of instruments that can analyze the rocks, in order to state that we have found evidence of past life on Mars, we need irrefutable evidence. What I mean by that is we need absolute proof that we found evidence in order for us to make a statement like that. And in order to do that, we can make some statements using the instruments that the rover carries, but we're going to have to bring those samples back to Earth and use state-of-the-art laboratories here on Earth that are way more powerful than anything that we can send to Mars today, and really tell us the final answer. We're also going to be characterizing the Martian climate. Different countries have contributed different instruments. Spain, for example, has contributed the instrument MEDA that will measure temperature, winds, pressure, and other things about the environment. We're going to be looking for rocks which could have been formed in the presence of water. Again, water is the key word here. We keep talking about water again, because if you think about it, again, as I said before, on Earth where there's water and there's a source of energy, there's the potential for life. Now, if you think about the size of the universe, there's billions of galaxies in the universe, right? And in each galaxy, there's billions of stars. And in each star, there's the possibility for some planets orbiting that star, just like on the solar system, right? So if we go to one of the closest places to Earth and we found some evidence of past life, that might mean that life is very common in the universe. I think that's incredible. Another objective of this mission is we actually carry instruments and experiments that are going to prepare us for future human missions to the red planet. In fact, the MAXI instrument will produce oxygen from the Martian carbon dioxide in the atmosphere. Now, we talk about bringing those samples back, and that sounds very scary and very complicated, and it actually is. So this graphic kind of shows what we're thinking about today. We're actually working very closely with the European Space Agency as part of the Mars Sample Return Program. And as you can see here, Mars Perseverance is actually the first leg of this program. We're going to find some samples that are very interesting. We're going to store them. We're going to leave them on the ground. And then 2 other missions in the future, not earlier than 2026, are going to be launched in parallel. One is going to launch an orbiter, a spacecraft that is going to be orbiting Mars, and another one is going to launch a landing platform with a small rover that will capture, that will grab those samples that Perseverance is gonna store, and then that platform will also carry a little rocket. I mean, how cool is that? We're gonna launch something to Mars, and it's gonna have a rocket on it. So what's the purpose of that rocket? Well, the little rover is gonna get the samples from Perseverance. It's gonna put them in the little rocket. That rocket is gonna launch into space, and a spacecraft orbiting Mars is gonna capture those samples and bring them back to Earth. That sounds like science fiction to me, but you know, it almost is, right? But here's the key, right? When a lot of people, you know, from all different places come together towards a common goal, anything is possible. So this is the challenge that we have ahead of us. Now, where are we going on Mars? There's a lot of interesting places, but we can only pick one. And this one is Jezero crater. It's a crater that has a very diverse environment, geologically speaking. It's over 3,000 million years old. And if you look at the picture here on the right side, you can see what looks like an ancient lake delta formation with all kinds of sediments that could have collected and preserved potential signs of microbial life. That's what we're looking for, right? And the site is very interesting too, because even the surroundings could contain hydrothermal environments. So environments that could have had some relationship to water. And that's, again, a key point of this mission, you know, looking for evidence of past life. So where there's water, or there used to be water, there might be evidence for that. Now, for some of you that are a little older, you might remember the Curiosity rover that landed on Mars on 2012. So our rover, our Perseverance rover, it's actually kind of similar to the to Curiosity on the outside, but it's actually very different on the inside. We have an instrumentation that is really focused and designed on looking for evidence of microbial life on Mars. On the outside, there's some differences that pop up right away. We have stabilizer in the back. We have improved our wheels so they last longer. We have 23 cameras, most of them in color. We have a very, very complex sample caching system that's going to allow us to collect rock cores drilled by the robotic arm. And the robotic arm at the end has a drill, has a device to clean all the samples. It has a spectrometer to analyze the composition of the rocks that we're going to be investigating. Now, when it comes to new technologies, and this is more my area of expertise, we actually have new capabilities that are going to allow us to land in the interior of the Jezero crater. One of them is range trigger. It's basically a technology that is going to deploy our parachute based on the navigated velocity instead of the distance to go. So that is actually fundamental because it reduces our landing errors by over 50%. Then we have a new system that we're going to fly for the first time on another planet, which is called terrain relative navigation. And you can see a little video there. Basically, the way it works is during landing, during descent, the rover is actually going to be taking images of the ground. It's going to compare those images to a map that it carries on board, and it's going to figure out all by itself where it is. And based on that, it's going to decide how to execute a maneuver, how to fire its engines and in which direction for a safe landing. So that actually really is a key feature that allows us to land inside of Jezero crater, because this crater, as it happens many times, scientists love science. They don't really care about where we land, but engineers have to make it work. So most of the times they pick a location that is not very safe. It's not boring and flat. This location in particular has lots of boulders, rocks, cliffs, dunes. So we want to avoid those locations. So that's why terrain relative navigation is crucial. Then we also carry additional pressure and temperature sensors. And we have something that I'm very excited about. We have additional cameras that are going to be taking pictures of the parachute deployment, the rover deployment. It's going to give us perspectives that we've never seen before during a landing. So that's very exciting. We actually carry two microphones, and one of them is going to be activated during descent. So we might hear some of the sounds as we fly through the Martian atmosphere. And in case you haven't been following, we have a really cool surprise. We're actually going to attempt to fly the first helicopter on a different planet. So we call it Ingenuity. and we're gonna demonstrate that power control flight in the very thin atmosphere of Mars is possible. It's a very, very small vehicle. It's about 2 kilograms. It's solar power. It has two rotor blades of about a meter long, and it has an altimeter and two cameras. So it doesn't carry any instruments. It's just a demonstration to really prove that we have the capability and the technology to fly on a different planet. We're gonna do some tests. They're gonna be very short, about a minute and a half or so. We're gonna go up to 5 meters in height. Our campaign is about 30 days. It can be extended. We might change this depending on how the different tests go. But the important thing here is that if we are successful, this might open up a completely dimension, a new dimension in Mars exploration. You can imagine that we might be able to access locations that right now are basically, we don't have the capability to get to, like caves or cliffs or holes on the surface. Now I have a little video that shows you how Ingenuity is gonna work. You guys, but I'm really excited to see taken by the helicopter of our own rover on the surface. Okay, so I have a few pictures here, so you get an idea about what the rover looks like. So this is a picture taken here at JPL in our assembly facility. So you can see this was part of a mobility test. The picture on the left is actually very close to what the rover looks like now in its flight configuration. So we have a heat shield at the bottom. The rover is encapsulated inside of that little cocoon that we call the aeroshell. And then we have a ring on the very top. Is the cruise stage that is critical for us right now because it's really helping us in our interplanetary flight. So on the way to Mars, we have solar panels that we use to charge our batteries on our flight system. We have engines that we use to execute maneuvers, to change our path, to make sure that we get to the right point on the Martian atmosphere. It also has heaters that dissipate energy. And you can see on the right, once it was on the launch configuration, which is still the configuration that we have now in flight, how we put it inside of the payload fairing of the rocket. Of course, that was one step of many. Then once the vehicle was integrated with the upper stage, it was put on top of the rocket, as you can see there. And we actually launched on July 30th. So I'm going to show you a video that I really like. It's really cool. It gives me a goosebumps. It was our first milestone of our interplanetary journey.
Minus 7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics.
Go.
LO2. Go. Water. Go. Electrical systems, airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. GCQ. Go. Operations support.
Go.
Com. Go. Umbilicals. Go. ECS. Go. Red line monitor. Go. Quality.
Go.
Op safety manager. Go. Relay safety officer. Go. Vehicle system engineer. Go. Knowledge. Go. Range coordinator.
Clear to proceed.
Launch director.
LD is go and you have permission to launch.
Proceeding with the count. ALC, verified T0 is set for 1150 zone.
4. Engine ignition, 2, 1, 0. And liftoff as the countdown to Mars continues. The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And we have successful separation of Mars 2020 with the Perseverance rover.
Our friends at the United Launch Alliance put us on a picture-perfect trajectory to get to Mars, and we're really appreciative that they did a phenomenal job. So you might be wondering, so where are we today? I mean, we're only 2 weeks away from entering the Martian atmosphere. So on this plot that you see here on this graphic, you can see the Earth orbit, you can see the Mars orbit, and you can see the trajectory, the path that we have followed to get to Mars. We have actually executed 3 maneuvers. So basically we have turned our engines on 3 times during the last 6 months to change the path to make sure that we get to the right location. It's not enough just to get to Mars. We want to go to a very, very specific place on Mars. So we actually have another maneuver planned for Tuesday of next week, which we might do or not, depending on how, if we need it or not. But we're actually closing into Mars. We're about 2 million miles away from Mars. We are about over 100 million miles from Earth, and we have already traveled about 270 million miles. So we have about 15 million miles to go, and we're moving really fast, screaming fast. So we're moving at a velocity over 60,000 miles per hour with respect to the sun, over 48,000 miles per hour with respect to the sun, and at about 5,000 miles per hour with respect to Mars. So we're moving really fast here, and we have to decelerate just as fast to make sure that we touch down on the surface of the red planet softly. And how we're going to do that? Well, we use just a very complex descent system that uses a supersonic parachute, a huge parachute about 60 feet in diameter. The biggest parachute that we have ever used is very similar to the parachute that we use for Curiosity. We have a propulsion descent stage that is going to slow us down during final descent. And I'm going to just let you watch this short video, because I think that that will explain it much better than I can do with just words. I don't know about you guys, but I'm really, really excited about this. It's going to be a historic moment, and I want you to remember that on this spacecraft, it's not just a NASA mission or a US mission. We're all going here. As humans, we're going to explore a new place that no human has seen before, and hopefully we're going to collect data that is going to help us increase our knowledge of our place in the universe. So I have just one more slide, but I have a video that I would like to show you. This is a video of the inside landing. So some of you actually might be old enough to remember this. We actually landed on Mars just a couple of years ago, November 26, 2018. That was my second landing, my second Mars landing, and I was very honored to be in the mission control room. And I gotta tell you, it's an incredible incredible journey. I was very privileged to be there, and I want to share with you some of those moments.
InSight is now traveling at a velocity of 2,000 meters per second. InSight has passed through peak deceleration. Telemetry shows the spacecraft saw about 8 G. InSight should now be experiencing the peak heating rate. Ground stations are observing signals consistent with parachute deploy.
Marco Alpha, Marco Bravo, maintain lock status.
Altitude convergence, the radar has locked on the ground.
Yes.
Standing by for lander separation. Lander separation commanded. Altitude 600 meters. Altitude 400 meters. 200 meters. 80 meters. 60 meters. 30 meters. 20 meters. 17 meters. Standing by for touchdown. Touchdown confirmed.
I get goosebumps every time I watch this video. So exciting. And so, yeah, so what time is it? It's about 12:33. So in about 13 days exactly, we should be getting confirmation of a successful landing on the surface of Mars. So I hope that you join us, and I hope that you found this presentation interesting. So thank you so much for your time, and I'm sure that you'll get more information about this through your school, but you'll be able to watch it live through NASA TV on the internet, and there's going to be many events, including some in Spanish. So thank you so much for your time.
Thank you, Dr. Fernando Abillerira. Everyone, please let's give Dr. Abillerira a virtual round of applause. Okay, now we're gonna go ahead and open it up for questions and answers just for a few minutes while we have this incredible NASA engineer scientist from the Jet Propulsion Laboratory, which is in Southern California. It's near LA. Okay, so Mr. Natividad, Ms. Martinez, can you guys please lead the Q&A session?
Yes. So we have a lot of good questions. So one question says, who will go to Mars in 2024?
Well, we are not planning on sending humans in this decade, but these missions that we're sending now are really going to help us develop the technologies necessary for a crew mission to Mars. Right now, NASA is planning on sending a crew mission to Mars sometime in the mid-2030s. But of course, all these missions are critical. They have to work, so we'll learn from them, and we are ready for the next step.
Thank you. There's a boy, Gio, that has been asking a lot of good questions. Gio, I opened up your mic. Go ahead.
Is the moon made of cheese?
Go ahead, Gio.
When is Mars? Everybody's gonna go to Mars.
When is anybody going to go to Mars? Well, hopefully in the near term, that's what we're working on, right? All these missions are helping us develop the technology necessary to send humans to the red planet. I mean, a rover is the size of an SUV, but you can imagine that if we want to send humans to Mars, we're going to need way more space than just a car. Imagine that you are inside of your car for 2 or 3 years. You need way more space. So we need to develop technologies that are going to allow us to land much bigger robots, much bigger habitats, much bigger modules and resources. So it's going to take us a while, but we're getting there. And hopefully in the next 20 or 30 years, who knows, maybe you will be the first person on the surface of the red planet.
Wow. I see Gabe. I'm going to open up your mic. Gabe, you can go ahead, ask your question.
Me?
Yes, Gabe.
Oh, I have a question. What if the rover accidentally lands in the wrong place?
Well, thank you so much for your question. That would be a problem because we send this rover to specifically, we send this rover and we designed this rover specifically for a function that is to search for evidence of past life. And we believe that the area that we have selected has a lot of potential to achieve this mission. So that would be bad if we land somewhere else because we might not be able to fulfill our mission. So hopefully everything goes as expected.
Okay, let's see. How can plants grow in Mars? That's another question.
Okay, so you've probably seen the movie, The Martian, which I think is a great movie, by the way. I really like it because it especially captures very well the environment within NASA, right? They, throw challenges at us, we'll figure things out, and that's the right motivation in life, You have a challenge, you work hard and you overcome it. So obviously you can't just plant something directly on the surface of Mars because the environment is very harsh. But if we have greenhouses like we have on Earth, and we have the right resources, then we might be able to live off the land, per se.
Thank you. Let's see. I see Natividad is your last name. Okay, ask your question. Go ahead and ask your question. Let me ask to unmute. Let's see, Mr. Natividad. Okay.
What was the hardest thing you had to overcome in school?
I'm sorry, it broke up a little bit, so I couldn't hear. Would you mind repeating the question?
What was the hardest thing you had to overcome in school?
Oh, what did I have to do when I was in school to do what I'm doing now? Is that what you're asking? Yes. Okay. So I actually studied aerospace engineering, and my background is in astrodynamics and orbital mechanics, which is basically a fancy word to learn about how planets move, how we can go from one place to another in space. That's kind of the things that I studied, and I became, kind of like an expert on that area of work. But the important thing is that you actually do something that you really enjoy and something that you're passionate about. And if you do that, you're going to become really good at it, and you're going to get, your dream job, and you're going to achieve great things. So no matter what it is, work hard and persevere.
Okay, I think we only have maybe for one more.
We missed Gabe real quick. We missed Gabe, Ms. Martinez. Let's get him to
Gabe, thank you so much. Gabe, go ahead.
Oh yeah, hello. Hi. I'm a little shy.
Oh, you're fine.
So I have a very interesting question to tell you.
Okay.
You know how in the Earth there's like lava inside it, or some hot chemical inside it? Well, do you think that maybe the water from Mars maybe like soaked in like a sponge inside the middle? Maybe.
Okay, Gabe, that's an excellent question, and I think it's a really good theory that you have, which is actually kind of true. So we've been talking about the fact that there's no water on the surface. At least we don't have direct evidence that there's water on the surface, but we know that there's a lot of water under the surface in a frozen state. You might remember that picture that I showed earlier of those blocks of ice, frozen water, basically. So there's a lot of water under the surface, and also in the polar caps, just like on Earth. And I'll tell you what, there's so much water on Mars right now. It looks like there's not a lot, but there's so much water on Mars right now in a frozen state, okay, that if all that water will melt, it would actually fill up the entire planet about 10 feet deep. So again, where there's water and there's a source of energy like the sun, there's the potential for life. So that's why Mars is so interesting. Good question.
Yeah, yes. Thank you. Thank you so much. Thanks everyone for joining us today. Thank you, Dr. Abillerira. What a remarkable presentation and talk. Folks, we're going to do this again next Tuesday and Wednesday. make sure you put it on your calendar. Teachers, principals, everyone, parents out there, stay in touch with your teachers, with your administrators. We're going to do this again next Tuesday and Wednesday. And then the week after that, we're all going to be online to celebrate Perseverance landing on Mars. Isn't that so incredible? We're going to be there with Dr. Abillerira and see the celebration as they celebrate, just like in the video that he showed us. So thank you again, Dr. Abillerira. This was an amazing experience for all of us, right? Once again, let's give Dr. Abillerira one more round of applause virtually. Come on, guys. Thank you, thank you. And this will conclude today's presentation. Thank you
so much for inviting me. And remember, everyone, you know, with work, with passion, with determination, anything is possible. So just reach for the stars, okay? Thank you.
Thank you for reminding us. Remember, we need you to come in and work with us, okay? You guys are the future astronauts, the future scientists, just like Dr. Abillerira, okay? So do your homework, listen to your teachers and your parents, and hurry up and join us. Come work for NASA. All right, thank you. Everybody take care.
One more message too. All you students with these wonderful questions that didn't get them answered, you could Google these and you could find a lot of answers to those questions. And if they still can't get those answers, definitely come back next week. And we have all these awesome professionals that probably answer them for you. Take care, y'all. Thank you. I appreciate it.
Thanks, everybody. Hey, I'm Mr. Natividad. Ms. Martinez, can you open up another room, please?